Okay, so today we're jumping into 10.3, solving radical equations. That means that in our equation we are going to have the square root of x. Somewhere, somehow, some way, our independent variable is going to be underneath the radical, and you could see it equal to something like 3, okay? Now, there is a property when we're dealing with radical equations, and that property is down below. It says that if a is equal to b, then a squared equals b squared. You can essentially square both sides of any equation and maintain the equality. So you'll remember when we were solving quadratics and we had x squared equals 9, we said that there was a property of squares where you could take the square root of both sides of an equation, add a plus or minus, and you maintain equality, x equals 3. Now the only difference here is that when you square something, you don't include the positive and the negative, okay? So for when we're looking at this example, we could square both sides of this equation. The square root and the square are going to cancel. We're going to get just x equals 3 squared gives me 9, okay? So this is essentially what we're doing today. Now, for these types of equations that we're going to be looking at, there's a two-step process, okay? It's very similar to the square root method that we've learned in the past. Step number 1, you have to isolate your radical. And for those of you that don't remember what a radical is, it's this symbol, okay? You'll see it a lot of the times referred to as square root when the index is 2. If the index is 3, it's the cube root, fourth root, so on and so forth, okay? The second step, once you've isolated the radical, is to take or square both sides. And square is a fancy way of saying raise to the second power. Okay, so when we're looking at the first example, letter A, okay, all we need to do is we need to get this square root of x by itself on the left-hand side or the right-hand side. It's already on the left, so let's just get the 5 out of the way. In order to do the opposite of plus 5, we're going to subtract 5 from both sides. You still have the square root of x, but now you no longer have the plus 5. You just have equals 8. From here, once we've isolated the guy that we wanted to, we just square both sides. The square root and the squared will cancel. You'll be left with x on the left equals 8 squared is 64. So your answer is x equals 64. These are pretty simple in the beginning, okay? They get a little bit more complicated, but this is essentially all we're doing. Now, the important part is when you follow this process, you have to check your answers, because when we're squaring both sides of the equation, you run into something called an extraneous solution. And that extraneous solution can pop up because, do you remember when we took the square root, we would get a positive and a negative result? Sometimes when you do this problem, because it's involving the square root, we have to make sure that when we plug it in, it still works, because sometimes you'll get a negative answer underneath there, and that can be extraneous because you can't take the square root of a negative, okay? So all we're going to do is take the 64, plug it back in. You'll get the square root of 64 plus 5 equals 13. This will give me 8 plus 5 equals 13. 13 does indeed equal 13. We've checked it. It's not extraneous, so we're good to go, okay? Let's do another one. Let's do B. In B, we would subtract 3 from both sides. Remember, we're trying to isolate the square root of x. We've got negative square root x equals negative 3. These 3's would cancel out. Then you divide by negative 1, divide by negative 1. You're going to get the square root of x equals positive 3. Then you're going to go ahead and square both sides. Now, the square root and the squared cancel. You get x equals 3 squared is 9. Always, 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 when you're using this method, check for extraneous solutions. So we are going to take this 9 and we are going to plug it back in to check for extraneous solutions. So we have 3 minus the square root of 9 equals 0. We plugged in 9 where we had x before. 3 minus 3 gives me 0. 0 equals 0. That is perfect, okay? So it is not extraneous. Now, I already know some of you are wondering, well, what does it look like when we get an extraneous solution, okay? You're going to have to wait till the very end of the notes to figure out what it looks like when an answer is extraneous, okay? So just be patient with me, all right? C, we've got the square root of x equals 6. Probably the easiest question we'll do because the square root is already, or the radical is already isolated. So all we need to do is take the square of both sides, or square both sides of the equation. The square and the square root will cancel. You'll get x equals 6 squared is 36. Always plug it back in. The square root of 36 equals 6. The square root of 36 is 6. 6 equals 6. We're Gucci, okay? Moving on, for to D, you should add 7 to both sides. You would get the square root of x equals 10. Then you're taking the square of both sides, and you've got x equals 100. Plug that 100 back in, you're gonna get the square root of 100 minus 7 equals 3. This is 10 minus 7 equals 3. 3 equals 3, we're Gucci. All right, now we're gonna jump down to some more challenging problems. They're challenging because our radical is no longer just x. Underneath our radical, in this scenario, we have x plus 2. So what we have to do is the same process. We're gonna move that 3 over because we want to subtract before we divide. So subtract 3 first from both sides. You'll get 4 times the square root of x plus 2 equals, and now on this side we have 16. Once you're done with that, then you're going to divide by 4. Divide by 4 because it's 4 times the square root. What undoes multiplication is division, so we divide by 4, these cancel out. The square root of x plus 2 is equal to 4. From here, now we've isolated our square root, now we can square. Do you see how the only thing we're squaring is the square root? Otherwise, you'd have to square other terms. You want to isolate it first, okay? Then we're going to square it. We've got x plus 2 equals 16. You subtract 2 from both sides, and now we've got x equals 14. Boom, bada bing. We're not done though. You've got to take this guy and plug him back in. So we're going to get 4 times the square root of 14 plus 2 plus 3 equals 19. This is 4 times the square root of 16 plus 3 equals 19. We know that the square root of 16 is 4, so we do 4 times 4. Guys, always, always, always simplify what's underneath your radical first, okay? Plus 3 equals 19. Now, by applying order of operations, I know I need to multiply before I add that 3 to anything. 4 times 4 gives me 16. When I add 3 to it, I indeed get 19. We're good. Okay, let's do C. 15 equals 6 plus the square root of 3w minus 9. So when we're doing these problems, same rules apply. We want to isolate this guy, get him all by himself. And that 6 is in our way, so we're just going to subtract the 6 over. We've got 9 equals the square root of 3w minus 9. Now we have our radical isolated. We can go ahead and square both sides. We're going to get 81 equals 3w minus 9. From this point, we're going to add 9 to both sides. We're going to get 90 equals 3w. Divide by 3, divide by 3. W equals 30. Once we have that answer, plug it back in. 15 equals 6 plus the square root of 3 times 30, and then minus 9. 15 equals 6. Always handle your square root first. This is going to be 3 times 30 is 90, minus 9. 15 equals 6 plus the square root of 81. 15 equals 6 plus 9. That indeed is correct. Okay, we've got 2 more sets of examples. Let's do it. All right, so when you see something like this where you have the square root on both sides, don't freak out, don't panic. So all you want to do is you want to square both sides, and the beauty starts to happen. Look, people. The squares and the square roots cancel on both sides. So this, what should look like a nasty, gross, disgusting problem, just becomes 2x minus 1 equals x plus 4. This is one of those linear equations that we've solved millions of these. You just subtract x from both sides. 2x minus x is going to give me 1x minus 1 equals positive 4 on the right. And then you just add 1 to both sides, and we've got x equals 5. Always take that value, plug it back in. You're going to get the square root of 2 times 5 minus 1 equals the square root of 5 plus 4. This is the square root of 10 minus 1 equals the square root of 9. Square root of 9 equals the square root of 9. We're Gucci. All right, and then we will do C as well. This one, square root on both sides, square them, okay? Squared and the square root cancel. We've got n equals 5n minus 1. You would subtract 5n from both sides. That's an n, not an x. Minus 5n, you get negative 4n equals negative 1. Divide by negative 4, divide by negative 4. We've got n equals 1 over 4, positive. And then always plug it back in. So we're going to get the square root of 1/4 equals the square root of 5 times a fourth minus 1. This is the square root of 1/4 equals the square root of 5 over 4 minus 4 over 4. Okay, 5 over 4 happened because I multiplied 5 by 1/4. 5 gets multiplied by 1, 4 gets multiplied by 1, and we get 5 over 4. The minus 4 over 4 came from 4. I wanted a common denominator, and 4 divided by 4 gives me 1, so I just changed the 1 into 4 over 4, okay? So now we have the square root of 1/4 equals the square root of 5 over 4 minus 4 over 4 is just 1 over 4, so we're Gucci, okay? All right, and for the last piece of information, go down to example 5. This is where we have the square root on one side, but we have our variable x on both sides. Watch what happens. So you would go about the same process. Make sure your radical is isolated. Square both sides. This and this will cancel. And we've got x squared equals x plus 6. Now we are dealing with a standard quadratic. Okay, so after we squared both sides, we get a standard quadratic. Now, we only spent a whole 2 freaking chapters learning how to solve quadratics. So you can pick any method you want. I'm going to do the easiest. You should always look to factor these babies, okay? So we minus x, we minus 6. We want to put this guy in standard form. We're going to get x squared minus x minus 6 equals 0. This is standard form. Look at the left-hand side. All we're looking for are 2 factors that when they multiply, they give us negative 6. But when you add them together, they give you negative 1. Let's make our chart. Multiply to give me negative 6, add to give me negative 1. And if you know what you're doing, you'd pick negative 3 and 2, negative 3 and 2. If you didn't get those, you need more practice, okay? So we get negative 3 and 2. That means that we're going to factor to x minus 3 and x plus 2 equals 0. Now it's tempting to be like, oh, x equals 2 and x equals negative 3. Stop. You have to set them equal to 0. And you have to do the inverse operation. So it's x minus 3 equals 0. So x is actually equal to positive 3. X plus 2 equals 0. So x is actually equal to negative 2. Now remember in the whole lesson when we kept checking for extraneous solutions, you all did this for this one problem because this one has an extraneous solution. So go ahead and plug them in. See which one's extraneous. You're going to find that x equals negative 2 when you plug him back in. He's going to give you negative 2 equals the square root of negative 2 plus 6. This is negative 2 equals the square root of 4. That's negative 2 equals 2. Now, it doesn't take a genius to recognize that negative 2 is not the same as 2. So this is your extraneous solution. So you'd circle this guy, cross him out, and your only answer that's not extraneous is x equals 3. So that should be the only one that you write down. If you write down both and you don't check for extraneous, you're losing points, peeps. Points that you can totally get. Okay, we're going to do one more problem and then we're finito. All right, so for A, we've got 13 plus the square root of 5n equals 3. You would subtract 13 from both sides. Because remember, you want to isolate that radical. Square root of 5n equals negative 10. Then you square both sides once your radical is isolated. Remember, squaring negative 10 is not negative 100, peeps. Negative 10 times negative 10 is positive 100 equals 5n. You divide by 5, you're going to get n equals 20. Again, Do not stop until you plug him back in, because he could be extraneous. When you plug in 20 into your original problem, you've got 13, and I'm writing in a highlighter. You've got 13 plus the square root of 5 times 20 equals 3. You're going to get 13 plus the square root of 100 equals 3. 13 plus 10, the last time I checked, is not 3. This is also an extraneous solution. This is why we check, people. So now the last problem had 2 solutions. One of them worked, the other one was extraneous. This one only had 1 solution and it didn't even work. So this actually has no real solutions, because we only got 1 solution. When we checked it, it was extraneous. All right, that's all this lesson is. Good luck.